Reading an electrical diagram, they can be pretty simple or they can be complex, and they've got a language of their own. Now, we normally talk and we use words, as you read here for the word resistor, chassis ground, electronic motor, or fuse. When I say those words, something comes to mind. You have an image of what's going on. Well, in an electrical diagram, they don't use words, they use symbols to say the same thing. So we have to understand the language of symbols. The language of diagrams always includes symbols, words, numbers, lines. All of this stuff is on there. And it's all for the purpose of helping us follow the map. Now, we're going to talk more about symbols as we go along in each one of these sessions. But when you're looking at an electrical diagram, remember, you're looking at a map. Not a street map, but a map of electrical current trying to find its path from positive to negative. Now, this is a map of Missouri. I happen to live in Missouri, in Springfield. I have a friend that lives in Kansas City. And if we both wanted to go on a trip and meet in St. Louis, I would take this road, and he would take the other road, and we would meet in St. Louis. Now, if this were an electrical map, this would be the power side, and this would be the ground side, and St. Louis would be the load. Now, the power, when you're color coding, the power road that is directly to the load is always colored red, and the ground road that is directly to the load is always colored green. That's true on our electrical diagrams. So on the map or on a diagram, first thing to do is locate the load. Now, a load is a device, something that consumes the power. It does work, like a light bulb, a blower motor, a coil. The second thing to do is locate the power source or the fuse that feeds the power. And the third is to locate the ground source, where the ground originates. In an electrical diagram, it'd look a lot like this. We first would locate the load. Now remember, this is a map, so this is your destination, where you want to end up. You'd want to have the starting point for the power, find the fuses in the power point. You'd want to find the ground source, the place where the ground originates. That's the first things to locate. Now you notice that they're both going to be pointing towards the destination or the load. So let's read an electrical diagram and see how all this fits together. In an electrical diagram, here's the three things that we locate before we start looking at the map. Notice the word up here, battery. Now that means the source of this power is the battery. Now, you know, a battery is not turned on. It doesn't have a switch. There's power in that battery at all times. So we're going to color that red because red means it has power at all times. Now, this leads us to our first rule. Voltage and ground always stop at an open circuit. Now, here this switch is open, so since it is an open circuit, that red or that power is going to stop right there. Always. Now on the ground side, it has ground all the time because it says G105. That means it is a body ground source. We're going to color that green because green means it has ground at all times. It's not turned on. If that is bolted down to the frame, it has ground. Now it confirms our rule that voltage and ground always stop at an open. Now the next power source over here, the word says start run. That means you only have power if you have switched to the start or switched to the run position. So that is a switched power. So we're going to color it orange. Anything in orange means it only has power when it is switched on or turned on. Now look down here at the bottom. You see this dotted square. This is the PCM. If that happened to be a solid square instead of dotted, that would mean it is all-inclusive. Everything is in there. But the fact that it's dotted means that there's actually more in this PCM than we're looking at. It is only displaying what we're concerned about in this diagram. Now, we look down here, we see that the PCM supplies ground for the fuel pump relay control. So we're going to color this yellow. Now, yellow means it only has ground when it's switched on. If you notice on the right, the red is power at all times. It is not switched on. And the green is ground at all times. It is not switched on. But if something has to be switched on the power side, we color it orange. or if it has to be switched on the ground side, we always color it yellow. Now this up here is an electromagnet. When an electromagnet has power and ground, it activates. And when it activates, it sends a magnetic pulse across and it closes the switch. Since that switch is not open, it is now closed, power can travel. It travels down to the fuel pump, it finds its ground, and the fuel pump consumes the power. Now, here's your next assignment. Find this diagram on my website for this particular video. I'll post these videos on my website, and with each one I'm going to post the blank diagram so that you can color it in. It'll be downloaded as a PDF file, print it out, and then color it in. Now here's what I want you to do. Go get yourself 5 colored markers. You're going to need them as we go along. Don't forget to do this. Our series is going to continue with lesson number 2. Watch for it in the next video. And don't forget, go get those markers.